currently 8 months that I am doing the work of a marketing manager for MSOs. Main reason is that I worked 12 years in an MSO, the main MSO in Spain, that the name was Ono, and in 2014 was purchased by Vodafone. Vodafone strategies in some countries, they purchase cable operators, like in Germany and Spain. And I worked about 12 years, and even I was not a specialist on coax, I know something about the network architecture, and that's the reason why I dare to do a speech about HFC networks and evolution. At first, what's the reason for evolution? The story of Gigaband access. First time I heard this word, Gigaband, was about 3 years ago in Huawei, when we presented the new products, new 10G PON evolution to customers, to say, come on guys, you need to go to 1 gigabit per second to offer 1 gigabit per second to your customers. Maybe they need it or not, but that was the story for the main manufacturers. 1 gigabit is needed. In fact, in 2015, this service was popular in Asia. I think some operators in Asia, they are offering 1 gigabit to the customers. And the reason, well, maybe we are talking about new services, education, cloud-based services, working, health, entertainment, that will require some rate to be downloaded at the subscriber. Maybe not today, because today, I want to use the laser pointer, but anyways, I think it's not working in this screen. For some reason, this screen reflects the light, and I cannot point. Today, Netflix requires only 4 megabit per second, HD contents 11, 4K TV 25. We are far from 1G, but we know in the future. I had 2 years ago an xDSL line, 4 megs, was almost enough for seeing the football in my home. Now I moved to fiber, FTTH, 50 megs. It's more than I needed. But you know, from the story, the engineers, we are bad people for looking at the future of services. I always like to say something in the past, maybe very long in the past. You know when telephone was invented, 1876? And the company has problems, and Graham Bell offered the patent to the telegraph company, Western Union. And a group of engineers meet and make a report. I made a lot of reports about tenders in my previous job. And they say, no, telephoning has a stupid idea. It will never work. And they refuse. I think it was $100,000, and they refuse. And about 5 years later, AT&T bought the Western Electric company. And then you know who got the first telephone? Directory number 1, US president. And I think it was Rutherford B. Hayes, not very known. And he got the telephone and said, oh, great invention, but who would ever want to use this? And when I started working AT&T in the 90s, we developed ISDN, 128 kilobit per second to the customer in the 90s. That's more than enough. Now we have 1,000 more, 100 megabit per second. And we may need 1G, why not? I think we may need. So, but first, where this Gigaband access term come from? Okay, since I am an engineer, this work, Gigaband came from bandwidth, and bandwidth means hertz. So it should be something like gigahertz. No, it's not gigahertz. If we model the access, digital access is a line terminal at the network side, talking with a network termination at the user side, subscriber, and transmitting bits. And these bits are line rates. And for transmitting bits, we are using the transmission media, and we are requesting some bandwidth from the transmission media. And you know there is a relation. There is a Shannon law that specifies the maximum bit rate that you can get for a given bandwidth. I will not put the formula. But the reality is that what we are getting is we are using bandwidth for transmitting symbols, changes in the light, changes in the phase, and converting this into bits. And what these systems are interchanges are bit per second. I will focus on the first layer, layer 1, physical layer. There are some layers on the top that used by the application, but for my presentation, I will do the comparison of different alternatives based on layer 1. Because layer 1 is always the same, it not depends on the application. This is a communication per bits per second. There is overhead, protocol stack. But for us, it's enough to say, okay, I will always be talking of the layer 1 level of bit line rate between the network and the subscriber. And at the beginning, it was defined narrowband. Narrowband making, well, we say user get bandwidth, so narrowband is narrow bandwidth. This is not an accurate term, but this is a good work, and okay, marketing made the rest. We will use bandwidth, narrowband for really talking about line rate and bits per second. In that time, when ADSL appears at the end of the 90s, 2 megabit per second was the limit. Narrowband was beyond or lower than 2 megabit per second. It was ISDN, it was HDSL, 2 megabit per second. And ADSL started offering line rate, I mean downstream line rate beyond 2 megabit per second, up to 8, I think. And then broadband was that, beyond 2 megabits. Now, in the GPON, DOCSIS era, it was redefined. Broadband has to be something between 25 and 500 megabit per second downstream to the subscriber. This is a new definition, a current definition. And now Gigaband is this. We define Gigaband as line rate between the network and subscriber downstream between 500 and 500 megabit and 1 gigabit per second. This is the new concept that manufacturers introduced for saying, hey guys, you need to evolve from GPON from DOCSIS 3.0. And this definition, to be complete, I have to add the upstream. Okay. What's happened here? This is not the last version. Okay, I make a few changes. Okay, one change is upstream. I will define, I need an upstream between 200, 500 megabit per second. Not necessarily symmetrical. So my definition of Gigaband is complete. Something between 500, 1 gigabit for downstream, something between 200, 500 for upstream. Okay, and then the question is, can our fixed access network support Gigaband access? Okay, xDSL. Well, xDSL definition is we have a DSLAM system, point-to-point with the copper, with the xDSL. DSLAM can be in the central office, but since important has to be sorted, DSLAM can be also in a in an FTTX architecture. And important is that this architecture is point-to-point, means not shared, means that all the line rate is for the single subscriber. The problem is that all the services have to use this rate. TV, voice, internet, all the services has to be point on the top of the line rate. The problem is that it's very dependent on the distance. When we started with ADSL 2+, we can get 20 megabit downstream, 1 megabit upstream, but with less than 1 kilometer. When we move to ADSL2, we can get 100 downstream, 400 upstream, less than 400 meters. And we need to apply vectoring. Vectoring is crosstalk cancellation technique. I did a project in Chile with Telefónica, and this is the real result for this with vectoring. Vectoring is not easy because all the lines have to belong to the same DSLAM. And if you are in a multi-operator environment, That's not easy to, or almost impossible to get. So it's a difficult to achieve. But still, it's because it's not valid for Gigaband. Next evolution is G.fast. G.fast promise 1 gigabit in total, and it's a TDM technology. You can transmit downstream, then upstream. To divide, you can divide 50%, 50%, 19, 10%, but they promise 1 gigabit up plus down in less than 100 meters. That's okay. They can, it's possible, but you have to get very close to the subscriber. But that's another problem. FTTH GPON, maybe you all know, we have an OLT system and the central office, and you have a single fiber with the splitters to the subscriber with the customer termination box, and then you get the patch cord to the ONT. And what current technology supports is a point to multipoint, means is shared. The line rate that we put in this line is shared between or amongst all the subscribers connected. And you can get with GPON 2.5 gigabit down, 1.2 gigabit up. I mean layer 1 with the headends and the story. This is not completely used for the customer, but this is layer 1. Okay, and how many subscribers are sharing this? It depends of the splitting ratio, it depends of the take rate. We have to do a model. If we want to compare, we have to do a model. If there is only one subscriber, you can get 2.5 gigabit, but that's not the reality. It depends. There are different situations. You can use centralized splitting, only one splitter. You can use distributed splitting. For this exercise, I will do a pessimistic model. I would say my comparison will be optimistic in HFC, pessimistic in the GPON. Could be something different, but this is the exercise. So I will use centralized splitting, and with centralized splitting, you can complete your GPON port. So I will assume you have 64 subscribers connected. This is not the case of Spain, for instance. Telefónica in Spain, they use distributed splitting, and maybe they have 45 subscribers per GPON. But there are other operators that use centralized splitting, and then with centralized splitting, you can put all the subscribers in the GPON, so I will use 64. And the other value, okay, I have 64 connected, but not all are demanding service at the same time. So I need another factor. You name whatever you want. I name service level agreement. Service level agreement is which is the minimum I guarantee to my customers. I will use 10% for this exercise. What means that if all the customers were connected at the same time, you will get at least 10% of what you contracted. In other words, the number of customers connected at the same time is 10%. And this is my model. I take value from Telefónica Spain. It was a value that they used in the past, this 10%. But this is not realistic. But this is just for this exercise. So using this model, 64 port connected, 10% subscriber at the same time, if you just simply divide, you can get per subscriber less than 400 megabit down, less than 200 megabit up. This is the service with this model comparison that you can get with the GPON. Still not enough for Gigaband server access, but there is an evolution path, that's quite clear. The evolution path is standard and defined, which is xGPON. With xGPON, you have 10 megabit downstream, 2.5 upstream, and then if you do the same exercise, you can get 1.5 gigabit downstream and almost 400 upstream, which is okay for Gigaband. And even there is a definition for 40G GPON, and the evolution path is quite simple because the wavelengths do not overlap. So using the same passive structure, you can smoothly change the ONTs to those subscribers that move to xGPON. So the evolution path for xDSL and GPON is defined. What about DOCSIS, HFC network with DOCSIS? HFC network with DOCSIS, the model is just a CMTS or CCIP system in your, I put something say hidden, but in my experience this is what we call primary node or hub. In the headend there are the TV system, and there are hubs beyond the headend containing the DOCSIS CMTS. You convert to optical, you get with your optical path until your fiber node. This is the demarcation point between fiber and coax. And from here, you have the coax part. Distribution coax, thick coax with RF amplifiers, and then the drop coax subscriber, and the cable modem at the subscriber side. Again, this is a share medium. So all the subscribers will share the line rate. And again, I have to apply the model. How many subscribers? This is even more difficult because the architecture of this network, it depends from operator to operator. You can have this demarcation point higher or lower, more subscribers or less. I will use the model that we use in Spain, which means this is 500 home pass, and downstream is split to 2,000 homes, and upstream is for 500 homes. This is the model. And the key here is the service group. What's a service group? Number of RF channels used for DOCSIS. Now, how many channels are we put in this model? Okay, I will say I will be optimistic here. We can put 16, we can put 32, I will put 64, which is more or less the limit. Very optimistic. 64 DOCSIS channels in an RF, share in downstream by 2,000 homes, in upstream by 500. I will use the same 10% level of simultaneously, and here the take rate, I will use the take rate that we have in Spain, which is 25%. So the number of connected subscribers is 500 downstream, 125 upstream, connected subscriber. 10% using the network at the same time. And the line data rate, using this service group of 64 channels down, 8 channels up, is 3 gigabit down, 200 megabit up. So what I call the equivalent subscriber line data rate using this model is only 64 down, 70, and this is the optimistic. This is the very best case. So we are very far from Gigaband. So something has to be done, and this is the next step, evolution. Evolution is not defined. We can go to DOCSIS 3.1, we can go to demarcation point closer to subscriber, we can go to FTTH. Why not? There are several possibilities. And my presentation is just to identify some of them, maybe some others, and I will talk about these alternatives that we in Corning are seeing as feasible. Okay, evolution path alternatives. First group is, okay, get demarcation point, the fiber closest to the subscriber. And identify 3 possibilities. Node split. There are operators doing node split. In UPC Austria mentioned, they are doing node split, which is just, I will keep amplifiers, but fiber is closer. The other is FTTL, fiber to the last amplifier, no amplifiers, fiber even closer. I think SFR France, MSO in France is doing this. And the other is the RFOG, radio frequency over glass, which is something that you can go to the home, TTH, or you can go to the building about 32 home pass, the 2 possibilities. The other option is upgrade to DOCSIS 3.1. And I can upgrade to DOCSIS 3.1, but I see different options for upgrading DOCSIS 3.1. I can keep the integrated CCIP, or I can go to a distributed CCIP, I will tell you what is, with remote MAC fee, or I can go to the same with only remote fee, which will be very similar to this one, so I put combination with fiber to the last amplifier, which is the solution chosen by Comcast in US, I think so. This is the solution by Vodafone Spain. Okay? And of course, FTTH GPON. There are many small operators, tier 2, tier 3 operators in Spain that finally they say, okay, I will do FTTH. And that's my story. Let's go one by one. First, node split. I am comparing the exercise with the model in Spain, which is n plus 3, which means 3 amplifiers in a row. So we are moving to only one amplifier. And we are moving from a fiber node with 500 homes to 125. So what I am doing in this is just to move the fiber node closer to the subscriber, dividing by 4 the number of connected subscribers. That's the basis. It's quite simple. I need extra fibers to get to the fiber node, but this part remains the same. I put this yellow triangle, means moderate capex investment. I will not put numbers here. I say, okay, this is not a big expense if you want to do this solution, not big investment. But your OPEX reduction, red box, is not very good. Your OPEX, my understanding for the OPEX in the coax network is due to the powering. You have active equipment in the street, and you have to power the fiber node, and you have to power all the amplifiers. This is a power consumption. And the other is the maintenance. You have failure, you have to adjust the amplifiers, and all this activity is almost not reduced here. You have almost the same number of active equipment, power reduction will be the same, still have amplifiers to be adjusted. But performance is okay, performance is good, because since we are dividing the number of connected subscribers, in fact, the equivalent subscriber line rate is multiplied by 4. So, using the same model that I will use in all the presentation, it's improved from 64/70 to 1G 17, 67. Okay, this is good for downstream. That's for upstream. For upstream is not good enough. So, this is a good step, cheap, but something else has to be done. Second option, fiber to the last amplifier. This option is the same as the previous, but we are going to move the fiber about 4 homes past, and we will remove all the amplifiers. I still consider this is investment in CapEx. You still are not changing subscriber, not the system in the CPO, extra ports, so much. And it's something the OPEX. We are removing all the amplifiers in the fiber node. We are adding extra optical to electrical converters, but in total there will be less active equipment, less power consumption, no amplifiers adjustment. Okay, it's a better solution from the OPEX point of view. And of course, since the fiber is closer to the subscriber, less subscribers sharing the service group, so the equivalent line data rate is bigger. Now, 2 gig in downstream per subscriber equivalent, that's very good. But still in upstream is not bad, but still something might be done. Okay, this is just an example I take from a internal presentation in Corning that is very good for showing what this fiber to the last amplifier means. Imagine that we call HFC today, which is the node, and which covering an area of 500 homes for sectors with the amplifiers. 3 in a row as a maximum, as you can see. And the evolution is something like this. No amplifiers. This place for the previous fiber node became a local concentration point for fiber, and we will move 8 fiber nodes to the place where the last amplifier was located. And each one will cover about 64 homes. This is a picture of what fiber to the last amplifier means. Okay, and latest scenario for getting fiber demarcation closer to the subscriber is this RFOG. With RFOG, we keep our CMTS system and we WDM here for transmitting downstream and upstream on a single fiber. And we cover this area, the whole possibility. The old presentation. This is not a splitter, it's a box. And here is, there are two options. If we are using FTTB and we put the optical to electrical conversion at the level of the tap, we will cover 32 homes. And we need a 1-to-8 splitter. If we are going to do fiber to the home, here I will put a 1-to-64 splitter and put here a box, not a splitter, just a connection box with no splitter. This is an option. In both cases, the number of subscribers connected to the PON will be again 64, because the take rate here is 25%, the same, and for covering this area, I will need 2 PON ports with 64 subscribers each. What's the problem of this solution is the CAPEX. My understanding with all operators in Spain that take this option is that this is very expensive. You need ports here, you need to replace your quad, your nodes, put splitters, and you need to put this RFOG, optical to electrical conversion, and network termination, the cable modem remains the same. But my understanding is that due to this solution is not very popular, these systems are very expensive. And also there is a problem in the upstream. There is an effect of several ONTs transmitting over the upstream wavelength at the same time called optical bit interference. And to cope with this problem, you need something at the splitter, you need an active splitter, sequentiator. So at the end, my impression is that this solution becomes expensive. Of course, in OPEX is very good. Green. For your active equipment in the system, maybe not so much in this case, but if you go to FTTH, the customer pays for the power consumption. And what about the performance improvement? It's not so good because you are setting the same service group, and in this case, with 64 connected subscribers, and it provides you a 534 equivalent service. So the solution is good from one point that you save OPEX, you keep your system, provisioning system, but maybe it's expensive and the improvement in performance is not so good. Something else has to be done. DOCSIS 3.1. Imagine that first option is to migrate DOCSIS 3.1 without changing anything in the HFC network. That means we will upgrade the CMTS, say integrated CCIP running DOCSIS 3.1, and also cable modem at the user home has to be changed. There is another thing that has to be changed because these all elements will not support more than 1 gigahertz of bandwidth. You need your all nodes or amplifiers for a new ones for supporting the bandwidth station up to 1.7 gigahertz, and that DOCSIS 3.1 requires. That's what's happening, my experience in Spain. They are replacing amplifiers. So I would say expensive solution. You have to replace a lot of systems. OPEX, nothing related to OPEX. We are keeping the same elements in the access network. Active equipment, power consumption, everything is the same. And what about improvement? Okay, DOCSIS 3.1, the service group, they say it can provide 10 gigabit in down, 1 gigabit in ups for all the service group. And here we are keeping the service group coverage of 2,000 subscribers down, 500 subscribers up. So at the end with the model, the performance is quite poor. 200 down, 8 megabit up. So this solution, as it is, without any change, doing any change in the coax network, seems that it will not fit for Gigaband. We have to do something else. For instance, remote MAC-PHY, distributed CCIP. Distributed CCIP, this is solution of Vodafone Spain. And in general, in the Vodafone group, I think they say, this is our point of view. We are going to change the CMTS in the hub by an OLT, deploy a PON system out till the fiber node, and put here a coax media converter, a TOX GPON to the network, and DOCSIS 3.1 to the user. But they will keep the coax. They will not change the coax network. They just move the DOCSIS from here, from the hub, to the fiber node. That's what they call remote MAC-PHY. Physical layer, MAC layer for the cable modems, move from the node, from the POP to the fiber node. This is important in terms of signal noise ratio, because you are applying your DOCSIS modulation, one modulation here, instead of here, and this length of fiber, you are gaining 6-7 dBs of signal noise ratio. So it's a solution good for DOCSIS 3.1. You will improve your modulation and your performance, but still, if you don't change anything in your coax network, the solution is expensive because they have to change all the amplifiers. They have to put the OLTs. They have to change all the fiber node by this system, the cable modem converter, and then you have to change your cable modem at the user. It's a expensive solution. In terms of OPEX, you still have the same number of active equipment, you still have amplifiers, but it's good in terms of performance. You can get equivalent 800 down, 80 up megabit per second to the subscriber. It's a good solution in terms of performance. But still, in terms of OPEX reduction, it's not good, but okay. These guys, Vodafone, get an agreement with Huawei, and Huawei will provide this solution. I was trying to sell this solution to Telefónica in Peru because they have a cable operator, and we did some trials, so I am quite familiar with this solution from Huawei. And they sell to Vodafone. It's good in terms of performance, but still, from the CAPEX and OPEX. Okay, next. What about distributed CCP, only remote PHY? Remote PHY means that, okay, we will still keep a kind of CMTS, we call CCIP core, with layer 2, dealing with the MAC, with the cable modems here, and do a point-to-point connection to the cable modem coax converter that only do the physical layer. Receive a signal, optical signal, and converts to the coax. Do the QAM modulation here. And I put an extra step, which is okay, and fiber to the last amplifier means I will, instead of putting this system at the fiber, I will put at the latest amplifier, and of course changing the cable modem. My understanding from our US team is that this is the solution by Comcast in US. Okay, solution is expensive in terms of CAPEX, because you have to improve, upgrade your CMTS, you have to put fiber, extra fiber, and 8 nodes, and still you have to change your cable modems and the subscriber. And it's not bad in terms of OPEX, it's an improvement. You still have active equipment in the system, but you have removed amplifiers. That's good. And what is impressive is in terms of performance. Since you have reduced the subscriber share in the service group to 64, and service group is now 10 gig downstream, 1 gig upstream, you get the amazing equivalent per subscriber of 6 gigs, 600 up. Remember that this is a model. But compared with the other model, the performance of this solution is impressive. And last but not least, GPON. Here is the model of Telefónica Spain with, well, no, it's not Telefónica, it's a distributed splitter. But you can put here 164 and here just connection boxes, it doesn't matter. And at the end, just to cover your 500 homes area, you need 2 PON ports from the OLT, and my model is that you will get these 2 PON ports full with 64 subscribers each. And you know what, GPON, you change your CMTS button OLT, change your HFC network by PON network, and the subscriber home change by ONT, which means a lot of money. Additional to that, this forces you to IPTV. In the other solution, I am not talking about OpTV in this presentation, but this is the only solution that forces you that, okay, CITV will not run here. So, well, will not run. We may say overlay. Well, okay, doesn't matter. But in the end, what I mean is that the extra cost is also for changing your IP system, but sooner or later you may be forced to do all IP evolution and remove your CITV system and put an IP system. But anyway, you have to invest to replace all the HFC network and replace all the subscriber home installation. So the solution is expensive in terms of CapEx, but it's the best in terms of OpEx. You will save all the OpEx related to power consumption in the active equipment and adjustment of amplifiers. And what about in my model? In my model, as you see at the beginning, is the same because it's a 64 GPON port and the performance is not enough for Gigaband. But the evolution is quite clear. Just put an X-GPON ONT here and an X-GPON port line card in the OLT. Evolution is defined and quite clear. And this is a comparison of the solutions that I presented. I presented these 7 solutions, and this is a comparison in terms of CapEx, OpEx, the performance, well, and even if you see here, there is a next step in each case. If we want to do, if we start getting the demarcation point closer to the subscriber, at the end, performance maybe still not enough, so a network evolution, DOCSIS 3.1, FTTH GPON has to be done. If we go to the DOCSIS 3.1 evolution, you can see here that we spend a lot of money, and in this case, latest case, we got a very good performance, so evolution maybe just to follow DOCSIS 3.1 evolution, maybe full duplex DOCSIS, whatever for the future. Your network is prepared for this. And if you go to GPON, you get very high investment, but very good reduction in OpEx, and you have to go to the GPON evolution path for increasing your performance. These are qualitative comparison. I did not make numbers. When I was in the ONO MSO, I make numbers because I have all the numbers. My network, my cost, everything, and I put everything together in an Excel, and you do the business case. This is just a comparison. Yeah, in this version, I don't have the conclusions. Conclusions. Getting the fiber close to the subscriber is good, but it's not enough for Gigaband. You also need a technology evolution. Technology evolution to DOCSIS 3.1 or GPON x GPON. And as I say, this is just an evaluation exercise. Every customer, every network, every actual case has to be compared with OpEx saving, CapEx expenses, your situation, your customers, to take the decision. And that's it.
Thank you, Ramon. That's most interesting. Do we have any questions, please? And while we're doing that, I'm going to have a fiddle with the air conditioning.
Okay, hello. Ramon, it's Paul Broadhurst from Technetics. Why do you believe that upgrading HFC networks is high investment? I don't understand. The I mean, you can divide up building networks, greenfield, to upgrading networks. Most of the work going on is upgrading networks.
Upgrading,
yeah. And most of the cost of building a network isn't really the network transmission equipment, it's the cables and changing the cables. So the reason I'm pretty sure that Liberty, Vodafone, Comcast, Charter, all the big tier ones in the world are upgrading HFC rather than going to fibre for upgrading existing is because upgrading HFC networks is much, much cheaper. I mean, on our analysis in Europe, where most of the cables are underground, it's roughly 10 times cheaper. On aerial networks, it's about 5 times cheaper. That's why they're all upgrading their HFC networks.
Cheaper than FTTH.
Than building FTTH,
yes,
yeah.
In my presentation I put FTTH as the most expensive.
You said very high investment,
Very high.
and then you said high investment.
Yeah,
You know, to me, high and very high sounds like they're almost very high. Okay.
No. This is a step. It's difficult when you don't put numbers, and I didn't want to put numbers here. I just want to be based on the
And the second reason why they like HFC, because I've been in this, well, I'm a new boy to this industry, I've only been in it 27 years, but I've been always hearing that it's all going to fibre in 5 years' time, and it's that 5 years has been rolling and rolling and rolling, but I'm more convinced than ever that it's not going to happen for at least 10 or 15 years, and because that coax, you can just, you've got duplex DOCSIS 10 gig.
Yes, of course.
Yeah.
When I talked to my previous colleague in Spain, now they are Vodafone, and I know they are moving to DOCSIS 3.1. But
That's right, yeah, we know.
Since they have to change all the amplifiers, we are wasting a lot of money.
But that's little money compared with rerunning all the drops. Micro
but
money.
if you go to tier 2 small operators in Spain, and operators in just a small region, 1 million home pass or less, they are doing FTTH. They move to FTTH. In some areas in Spain where there are small operators just for this area, because Vodafone is the whole country. But in this area, they go to FTTH.
On new build?
On the existing brownfield, yes. In some cases, they decided for greenfield, they decided FTTH, even Vodafone. Vodafone in Spain, for greenfield, they will go to FTTH, but because they have to spend the money on the upgrading of DOCSIS 3.1 of the HFC network, they make an agreement with the Spanish incumbent, with Telefónica, to share the fiber. They will use the fiber of the incumbent in Spain, while they spend the money of upgrading the DOCSIS. In the future, they will do the FTTH. But you are right, that it's just a flavor comparison. But I know that big MSOs prefer to upgrade the HFC, is their business.
It's the accountants driving it. It's all about cost.
There are not enough good engineers around, and FTTH is easy. There are not enough RF engineers.
But it's more expensive.
It's too complicated for them, and they don't want to have the...
It's all about finance.
System.
Yeah.
The cost of it really, if you give them 150 megabits, they are quite happy. You can do everything in your house, as long as 24 hours a day.
Yeah, that's
and HFC sometimes goes wrong. There's not enough engineers to sort it out. That's a problem.
Yeah, and there is always the difference in mindset between telecommunication companies and cable operators. Cable operators typically look for ROI in the 2 to 3 year period. A telco typically looks at a 10 to 12 year period. So investment for long term is much more likely from a telco company.
Okay, thank you.
Chris Bailey from PPC. By the way, we still make F connectors, lots of them. My question sounds slightly naive. You you brushed over the G-fast technology, and I'm not involved in it anyway at all. Just what I've read in the technical press about some of the trials that British Telecom are doing, BT. And I think something like 13 or 14 cities, 1.4 million home trial that's going on. And it looks to me as if that's potentially, you know, a sleeping killer solution, really. You put it out there as 100 meters, and I've been reading that there's a relationship between the distance and the bandwidth, where at 400 meters it's still, they're finding in excess of 300 meg down, which I think for everyone in this room is probably more than enough.
Yes, of course. I know that, how to say, even there is another technology in between, which is super vector, that you can improve at 500, 600 meters until 300 megabits. That's true.
Yeah.
But my presentation was focused on
Sure.
1G.
Sure. Yeah.
So for 1G, I say, okay, it's possible, but you need less than 100. I have other presentation for xDSL, compare the full situation. And that's true that G.fast is better than VDSL at, say, 400, 500, 800 meters.
I agree with Paul. I think it's, at the end of the day, it's all about sweating the assets, you know. It's what you've got there and what you can get out of what you've already got.
Yeah, that's the reality. The problem is that you have to be very careful with the crosstalk, and you have to power the equipment, and you have to find a place for the cabinet or bury in the main hall. That's difficult stuff. But then there are operators, British Telecom, Swisscom, Deutsche Telekom, that they are using G.fast.
Yeah.
Yes.
Okay, thank you.
Yeah, thank you for asking. Okay, thank you.